Now I can show you some calculations, how to calculate the confidence interval for the difference of means for our case, WADA and RIBA. So that will answer the last question, right? Can we say that the average content in WADA river is different than the RIBA river? Okay. So I will just remind you some statistics that we have. So let's start with this are WADA. This is, here we have RIBA. Okay. So the average values. So let's start with average values, and then standard deviations, and then the sample size. Okay. So the average value for WADA is 152.1, while for RIBA it's 139.3. Okay. Then the standard deviation is 9.3 here, and I use 9.9 here. And then we have sample size is the same. It's 10 and 10. Okay. So the question is, can we say that they are different or not? Meaning rivers, not the samples, of course. Samples are always different. Okay. So first of all, let's calculate the difference of means, M1 minus M2, which is 152.1 minus 139.3, which gives us 12.8, right? 12.8. 12.8. Okay. So this is the real difference we got. So in our sample from WADA, these 10 glasses of water from WADA were more contaminated than 10 glasses of water from RIBA. How? In average, it was plus 12.8 milligrams per liter. But will it be the same for the population? It can be smaller, it can be larger. We don't know yet. Okay. Well, first of all, we need to calculate the standard error for the difference, right? So this one. And because the sample size is the same, and then I assume that the standard deviations for the populations are equal, I can use the formula I have shown you before. So it's just we take S1 squared plus S2 squared, and divide to n. Okay, and divide to n. And then it gives us 4.3. If you just put the values and calculate it, it will give you 4.3. So this is the standard error. This is the standard error. Let me show you some intuition about this formula, why we use this formula. Okay, you remember that standard error for just one average, it's s over n, square root of n, right, like this. Or you can think of the following: it's s squared over n. Okay. Or you can just rewrite it like this: it's s and then 1 over n. Okay. Now we have two samples, and each has a standard deviation, right? So it can be reasonable that our s or s squared will be just a average of the variance that we have. Okay, why? Because well, we have the same variance in the population, but the sample it's not the same. So let's take an average and use average for the standard deviation, right? So it will be just s1 squared plus s2 squared divided to 2. So that's the average, right? And then because again we have two samples, so instead of the square root, this one, we should write it like this: it's square root of 1 over n1 plus 1 over n2, right? But what is this? This is just because we have the same n, it will be 2n, right? 2n, because we have the same sample size. Now let's just combine this together. So the sigma for m1 minus m2 is the square root s1 squared plus s2 squared divided to 2. It's average variance, and then we have times 2 divided to n. Okay, and then we just get rid of this, and we got the formula that we used. Okay, so that's just a little intuition about why we use this formula. Okay, now we need to calculate t for getting the confidence interval. We need to calculate t, and let's start with 95% confidence. So we have confidence level is 95%. Okay, well, we don't know how many degrees of freedom. Let's think. We have n minus 1 degrees of freedom in the first sample, right? Plus we have n minus 1 degrees of freedom in the second sample. So it gives us 2n minus 1 or 18 degrees of freedom. Okay. Now we need to calculate the t. Now we can calculate the t value for 0.975 and 18 degrees of freedom. I will use again ICDF function, so I will just calculate it like q, t, and then 0.975 and 18. And this is 2.1. Okay. Now we can calculate the error margin, which is the 2.1, the error margin. I will use it like this. It's 2.1 times 4.3, which is, it's 9.03. I will just use 9. So this is our error margin, okay? Now the confidence interval, we can calculate the lower boundary, mu1 minus mu2, the smallest possible, the lower boundary, is the real value 12.8 minus 9, which gives us 3.8, of course, which gives us 3.8, okay? So that's the smallest possible difference. Then the largest possible difference, mu1 minus mu2 up, okay? It's 12.8 plus 9, which gives us 21.8. So this is the confidence interval for the difference of average chloride content in the rivers. And it tells you that, well, it seems like average chloride content in Vada is larger than average chloride content in Ribe. How big the difference is? Well, at least 3.8 milligrams per liter with 95% confidence. Maybe up to 21, we don't know, but at least 3.8 milligrams per liter. And then I recommend you try to calculate the confidence interval for 99% confidence. So it means that you need to change only a t value and find out if it still shows a difference, or in this case, it will cross 0.